This is problem 2 of my midterm video assignment, part 2, computational portion. It says the annual cost in thousands of dollars of manufacturing X thousand sets of wireless earbuds is given by C of X equals 0.001x cubed plus 3x plus 100. And no more than 60,000 earbuds can be produced in a year. All right, the first part is find the average cost function. So we know the average cost function can be found of C of X over X, which we can use the information given, G equal to 0.001 x cubed plus 3x plus 100 divided by x. We could simplify this further, but for the time being, this is enough. And then part 2 asks how many earbuds should be made in order to minimize the average cost per set. Use a second derivative test to confirm. All right, so first we need to get the first derivative of this. So C prime of marginal x, that is equal to, it would be equal to d over dx of this first part, top part 0.001x cubed plus 3x plus 100 multiplied by bottom part x minus just 0.001x cubed plus 3x plus 100 multiplied by d over dx of x divided by x. Okay, and x squared. Yep. Okay. So now we can 0.001 times 3 is equal to 0.003 x squared plus 3 multiplied by x minus 0.001x cubed plus 3x plus 100 multiplied just by 1 over x squared. And so now we can simplify this even further by, we can multiply x first, 0.003x cubed plus 3x, and then minus 0.001x cubed plus 3x plus 100, yep, over x squared, which can be, alright, so these values can subtract from each other, which is 0.002 x cubed, right, and then 3x minus 3x cancel each other out, and then minus 100 over x squared. Okay, so this is the first derivative, 0.002x cubed minus 100 over x. So now we want to find when this equation equals 0, what is x's value? And for this part, I'm just going to use technology x equals 10 to the cube root of 50, which is equal to 36.84. So, yeah. Okay, so now we want to use a second derivative. So now we want to get this c prime of x to test this value, see if it is a minimum. So now we do this process again over here, which is going to be d over dx of 0.002x cubed minus 100 multiplied by x minus 0.00, sorry, this is x squared, x squared minus 0.002x cubed minus 100 multiplied by dx of 2, x squared, x squared over x to the power of 2, but x squared to the power of 2, right? Okay. So now we have to simplify this. This first part can be simplified to 0.006x squared minus 100 is 0, multiplied by x squared minus, this is going to be 0.002x cubed minus 100 multiplied by 2x. Okay. And this is over x to the 2, which we can get to be x to the 4th. So now we can simplify this even further, which is going to be okay, 0.006 x2 x2 minus, that is going to be multiplied by 2x 0.002x cubed minus 100, which still over x4, and that can be simplified to 0.002x cubed plus 200 over x to the 3. So now that we have double prime, let's go back over here. Equals 0.002x cubed plus 200, 0.002x cubed plus 200 divided by x cubed. Now I plug this into Desmos, and I found out that of 36.84 is equal to approximately 0.006, whoops, 0.006, which is greater than 0, which makes it minimum. Okay, so we found out that this value right here was indeed a minimum. And then now part 3 asks for what is the minimum average cost. Okay, so we use this value and we'll plug it into the average cost value over here, which ends up being this right here, right? And I plug that into Desmos, and this C of 36.84 equals approximately 7.07, and we'll add 1.6 because this is in thousands of dollars. So multiply by 1,000, 1, 2, 3, and you get 707, 1.6 dollars. That is part C. Okay, so this is the average cost function. This was the minimum value, and then this was the minimum average cost. And even now, when I look at the graph of the average cost function, if I look at the graph of it, I can see that the minimum point is at exactly 36.84. So the slope going from the left, the slope going from left to right, as it goes to that point is negative, but as soon as it hits that point, that's when you can start to see the slope to go positive, and that's how you get the minimum. That's how you understand the minimum value and figure out how many earbuds should be made in order to minimize the average cost. Okay, that was part 3, or that was part 2, conceptual question. Thank you.